Hey, this is Math 7 Unit 5 Lesson 15, solving equations with rational numbers. So we're going to solve some various equations today that include some negative values as well. Alright, so here we go. Just first, some number talk, talking about opposites and reciprocals. The variables a through h all represent different numbers. Mentally find numbers that make each equation true. And so really it's a mental math thing here, but you can also just solve it. That's fine too. And so we're thinking about here, how does this work out? You know, excuse me, 3 times 5 is 15 and 5 times 3 is 15. And so the number that works out here is going to be actually just 1. Here, because I'm looking at a reciprocal, to get to 1, if I have a 7, if I multiply that by the reciprocal 1 over 7, then I end up with something that looks like 7 over 7, which is simply 1. So the idea here is to look at what might be happening with these other letters to see what you can get to get the values, whether it be 1 or 0, what that might be here. Okay? And so for C and D, you can have anything. You can have a half and 2, because now you're multiplying by the reciprocal, and you're oh goodness, and you're good to go. Here you have negative 6 plus 6, and so since those are the opposites, right, you're going to end up with a 0 value. Here, because I'm trying to get a 0 value, I'll find the opposite of 11, which would be a negative 11. And here I can select any value I want. I could put 7 and negative 7, whatever that might be, because I'm looking at two opposites that will go together to make that 0 value there. Okay, down below, let's look at the solutions here, matching solutions. Let's match the equation to its solution. And so to do this here, we're going to do some some math work. So to get the half to go away, I multiply both sides by the reciprocal, which is 2 over 1. 2 over 1, negative 5 times 2 is equal to a negative 10. And so this one here is going to match up with x equals negative 10 right there. For this one, I'm going to divide both sides by negative 2. A negative 9 divided by negative 2 is going to be a positive 4.5, or a positive that, or positive 4.5, however you want to look at that. And so this value matches this one right there. For C, we're going to multiply by the reciprocal, which is still negative 2. So we multiply it by negative 2. And negative 2 over 4 is equal to negative 2 fourths, which is equal to negative 1/2, which matches this one right here. Here we're going to divide by negative 2. So 7 divided by negative 2, I can change that into a negative 7/2, which can be also written as negative 3.5, which matches this guy right there. And this one here, we have add a negative 2. So let's, instead of adding a negative 2, let's go ahead and we can subtract. Well, we can add a positive 2. So we're going to add a 2 over here and add a 2 there. And so that's going to become a negative 4.5, negative 4.5, which matches the first one up there. And then finally, to get the x by itself, we're going to add a 2 and add a 2. So 2 plus a half is 2.5, or 2.5, and that matches choice 5 right there. So all these we're basically doing, we're adding opposites, multiplying by the reciprocal, just working through that process there again and again to make sure you're comfortable with it. And that's a lot of what these last few lessons in this unit are going to be doing. Okay, the hiking club is on a trip hike up a mountain. The members increase their elevation, so that's adding there, 290 feet during their hike this morning. Now they're at an elevation of 450. Explain how to find their elevation before the hike. Okay, so to find the elevation before the hike, we're going to say, well, where are they now? They're at 450. We know that they went up 290. So to find out where they were before, let's go down 290. So we'll take 450 and then we'll subtract 290, and that'll give us their elevation before the hike there. Hans says the equation e plus 290 equals 450 describes the situation. What does the variable e represent? Okay, so, well, in our case up here, we can make e be the elevation for where it's going to be. And look at this equation. Does this equation have anything to do with that one there? In this case, we would say they do. The elevation is what the e stands for. Okay. In this case here, it's elevation before the hike. So he's setting it to say, we started at a certain point, we went up 290 feet, and we arrived at 450 feet, which is what we did before, right? If I want to solve for E, I subtract 290 from both sides. So that E equals 450 minus 290, right? Which is the same as what we had up here. Hans says he can rewrite the equation as E equals 450 plus negative 290 to solve for E. Okay, would we agree with that? Sure, because 450 minus 290 is the same as adding the opposite, right? And so what he says here matches what we did up here. And so we're on the same path. Everything is the same, just a different way of setting it up, but the same exact solution. Okay. The temperature fell 4 degrees in the last hour. Now it is 21 degrees. Write and solve an equation to find the temperature it was 1 hour ago. Okay. So the temperature was something, right? Like our last time, that's what the temperature was. It went down 4, and now it's at 21. So that could become our equation. Some temperature minus 4 gets you to 21. So to solve for x, we add 4 to both sides. And so the temperature for an hour ago was going to be 25 degrees. Number 3. Says there are 3 times as many students participating in the hiking trip this year than last year. There are 42 students on the trip. Explain how to find the number of students that came on the hiking trip last year. Well, we know this year there's 3 times as many students. So this year we have 3 times the number of students, and we know that in this case here, we have 42 this year. So last year, the number of students, if we took that value and multiplied it by 3, that tells us how many we have this year. So to find last year's value of students, S, we'll take 3S and make it equal to 42. Let's divide both sides by 3, or again, this is the same as multiplying by the reciprocal. Same idea, okay? Just depends on what you want to talk about. And so our number of students is 42 divided by 3, which was 14. So we had 14 kids on the trip last year. May says the equation 3s equals 42 describes the situation, which is what we did there. Got it. What does the variable s represent? S represents the number of students last year. And that's really what that is. The number of students last year is what the s value is. May says she can rewrite her equation as s equals 1/3 times 42 to solve for s. Compare May's strategy to your strategy for finding the number of students on last year's trip. Again, if we had 3s and we set that equal to 42, what we're doing is we're multiplying by the reciprocal. So this becomes eliminated, and you're left with s equals 42 times 1/3. Which matches what she's doing when she rewrites that, right? So it's the same idea of what we did before. It's the same as 42 divided by 3, except now you're just showing it as multiplying by a reciprocal. The cost of a hiking trip this year is 2/3 the cost of last year's trip. So 2/3 of last year's. This year's trip is 32. So what we want to do is we look at 2/3 of last year, and we can call that cost. 2/3 times the cost is the trip this year. So this year is $32, and so 2/3 of last year is going to equal this year's trip. So write and solve an equation to figure that out. So again, we have 2/3 of last year, we'll call that C for cost of last year, equals this year. So to find out what the cost was last year, I'm going to multiply by the reciprocal on both sides. All right, so this gets eliminated. So I'm left with the cost equals 32 times 3/2. And I can reduce, 2 goes in here 16 times, and 16 times 3 for our cost is $48. So last year the cost was $48. This year it's 2/3 as much, and we're down to 32, which makes sense because it's less than 1, right? So our price is definitely reducing from $48 to $32. All right, that's the idea there. Now you have a card sort activity that you might be doing in class today. And so for this activity, we can see that we have a set of cards, and they want you to match numbers with the additive inverse. This is one of the first things I want you to do. The additive inverse means we're looking at the opposite signs, right? So you're looking at something like 2 and a -2. Those are opposite signs there. something along those lines. If you have numbers you're matching the multiplicative inverses, okay, that's going to mean they have the same sign, but it's going to be something along the lines of a -3 and a -1/3. Okay, so we're basically doing the reciprocal, we're flipping that over there. Okay, so for the multiplicative, they need the same sign, but to be an additive inverse, they're going to have the opposite sign. And then you can do that with your card sort today, and off you go. All right, so in summary of today's lesson real quick, I haven't done a summary for a few lessons. We can say that we can always add the opposite of 8 or -8 to each side. So when we have an equation, we can add the opposite, and that helps us get the variable by itself. Another thing we can do is we can multiply by the reciprocal to find out what, to get a value by itself is going to be. And those are the two steps we tend to do when we're solving for various equations. All right, let's take a look.